All right, we're recording. Today we're going to talk about 10.4 inscribed angles. So what are inscribed angles? An inscribed angle is an angle that comes from the corner of the circle. Now makes that special is that when it was from the center, they were the same size. So let's say if you had an angle like in the center of the circle, from here to here, if this arc was 84, then this angle also was 84. So sometimes we just kind of refer to one as the other. We didn't really make a difference between the two. In this part, we have to make a difference. When a circle is going from the edge of the circle and is intercepting this arc, this is called an intercepted arc, and this is called the inscribed angle. This angle is going to be half of the arc. So if this is 84, angle A should be half of 84, which is 42. That's a rule that has to happen. So that's just like a law. And because of that law, we could do a lot of things with that. That's like the basic part. And let's talk about what we could do with that. Like number 4, if this part is 70 and this part's 120, and you know, because you're smart, that a full circle is 360, you could do 360 minus 70 minus 120 to find this part right here. So that's 210 minus 360, 150. So if this little part is 150 degrees, this is an inscribed angle intercepting that arc. So because it intercepts that arc, it should be half the size. So your answer for number 4 is going to be half of 150, which is 75. Next one.
Wait,
NL.
I have a question.
Yeah, go ahead.
For number 4, I got 85.
70 plus 120 is 190. 190 minus 360.
170 plus
170. You got it. Thank you. I did my math wrong. Since this is 170, then this should be 185. 85. My fault. I did the subtraction wrong. Okay, next one, number 5. NL is a diameter. Now, a diameter cuts a circle in half, makes it a semicircle. If that's true, then this red arc that I'm coloring in should be half of a circle, which is 180. If this part in black is 160, then this has to be, this part right here, 180 minus 160. So this little part right here is 20 degrees. But as we said, the inscribed angle is half the size, and the inscribed angle being this one over here. So that should be half of 20, which is 10. So it's 10 degrees. Okay. So if it's half, if the angle's half the arc, then the arc is double the angle. So here in 6 to 9, or 6 to 8, it's just a reverse. If this is 67, then the arc, RS, has to be twice as much. So if it's 67, this should be 134 degrees. Just because it's double, the reverse is true. Or is inversible, I should say. Here, they're pointing out the angle here is 30. But look at what they're asking us to find. DU. So we're looking for this arc right here. So before we find that arc, well, let's point out some things. TU is a diameter. So right now, from T to U is 180 degrees. If this angle right here is 30 degrees, that means this arc is going to be twice as much, which is 60. And just as we said, from T to U is 180. So VU is just going to be what's left over. So 180 minus 180 minus 60 is going to be 120. And then number 8, WX. So WX is this piece right here. So we have to find the missing pieces and then probably subtract that out of 360. They already give me this one, which is 110. And they give me a side one here. If this is 75, this part right here has to be double. So it's 150. If a full circle is 360, that means WX, which is the last piece we don't know, is going to be needed to make 360. So 150 plus 110 is 260. Then 360 minus 260, this one right here, should be 100 degrees because we subtract these two pieces from 360. So this should be 100 degrees, yeah. Okay. I went through that pretty fast. Does anyone have any questions on that? All right, so that's the basic rule of it. So the basic rule is the angle's half the size. With that information, we could do a lot of things. First off, let's talk about number 9, I guess, because I did include that. Number 9, what's the error here? If this is a diameter, that means this half circle should be 180 degrees. But they said this angle is 45, which would make this RS 90 degrees. When you do 100 plus 90, that's 190, not 180. So you could say two things. You could say QR cannot be the diameter because it doesn't add up to 180, or this cannot be 45 degrees because it does not add up to 180. The fact of the matter is that it has to add up to 180, so either you're changing the little angle or you're changing the fact that the total is 180 by changing it and saying it's not a diameter. So something along those lines. It's not actually a diameter, or it's not actually 45 degrees for number 9. Okay, number 10. So with the rule that it's always half the size of the arc, that means if two angles share the same arc, the intercepted arc, the two angles should be the same because they're sharing the same arc. So look at DC, arc DC, angle B, DBC, and angle A, DAC, share the same arc. Because this arc, let's say it was like, I don't know, 80, that would mean both of these angles have to be 40 each. And I could put an infinite amount of angles into here. As long as it shares the same endpoints, they're going to be congruent. So one pair that's congruent is A and B. I should write it correctly. Angle A is congruent to angle B. And another pair that's congruent is that this angle here and this angle here share the same opening over here. So that means C and D is congruent also. Okay. These kind of repeat themselves, so I'm going to leave those for you because I don't want to hold you guys too long. So leave a little gap for 11 and 12 if you're doing this right now, because I want to skip right to 13. 13 is a little bit more interesting. So 13, there's another situation. I already explained in the YouTube video, so I'm not going to spend too much time on this, but the basic rule is that the diagonals of a quadrilateral, I should say, the diagonals of a quadrilateral inside a circle, a lot of restrictions, are going to be supplementary. And we got to remember what supplementary means. Literally chapter 1 stuff means that it adds up to 180. So angle R and angle T should add up to 180. So it's x plus 80 equals 180. That means x has to be 100. Same is true for the other diagonal. 95 plus y should equal 180. You subtract 95 on both sides. Y should be 75?
How do you know this? Like, how
There's-
can you assume?
I explained it in detail, but basically as quickly this. Let's say angle T, we're going to take T and R, right? They're opposite angles. T covers this space right here. And R covers this space right here. I'll use a different color. So you see how the both angles cover both parts of the circle? Now, if it covers the whole circle, that means both of them added together should be 360. But these inscribed angles are half the size of the arc. So if they add up to 360, like the arcs, then half of that should be the angles. So half of a circle happens to be 180. So that's why they add up equaling 180. And I go into more detail if you want to rewatch it. Or I assume you guys were at Rubin, so I don't think you guys were able to watch it, but whatever. You can check it out. I explain it in much more detail. But that's the basics of it. What you need to remember as a student is to remember that diagonals are supplementary. Mathematically, that's all you need to know about it. So like, I'll do number 14 also. No, I'll do 14. But 14 is D and F are diagonals, and this is happens to be a trapezoid. So D and F is diagonal. Actually, I can't say this is a trapezoid for a fact. Not yet, at least. So that means that these should add up to 180. So 60 plus 2k equals 180. Do your algebra. 60 subtract on both sides is 120 divided by 2. K should be 60. And then you're going to do your m plus 60 equals 180. That's a little easier. You just subtract 60 on both sides. M is 120. Okay. Well, it's almost finished. Number 15. This one is a little tricky. They're like, well, they don't give you the angles directly, but we can still figure it out. So first off, I know every polygon or every quadrilateral in a circle, inscribed in a circle, should be supplementary diagonals. But I don't have the diagonal for this part. I don't have the K. But I can see K includes this arc. So I have the information to find K. So I could find K by doing 54 plus 130. So 54 plus 130 should be 184. If this whole red arc that I drew is 184, this angle here should be half of 184, which is 92 degrees. So if this one's 92 degrees right here is 92 degrees, I can do 92 plus 4b equals 180, because now I have both informations. I can set them into a supplementary situation and solve. Subtract 92 on both sides, I should get 88. 4 divided by 88, or 88 divided by 4, I apologize, should be 22. So B in this one is 22. And then A, same situation. I don't know what J is, but I have arc, the blue arc here, of J. I have enough information to tell that. 130 plus 110 should be 240. If that's 240, I could cut that in half, and that's 120. So this J angle is 120. That means 3A plus 120 should give me 180. So I could do, I'll set it up for you guys. 120 plus 3A equals 180. That's a bit sloppy, but whatever. Subtract 120 on both sides. You got 60 equals 3A. Divide 3 on both sides. A equals 20. Okay? So what you need to remember is that the diagonals are supplementary. Why they are supplementary, I could explain that again, but I feel like you don't math that part, so I just explained it in another video. Any questions on that? Okay. If not, I'm going to clear this. And what we're going to do is that for number 18, you're going to figure out what to do, and you're going to send me the answer. Now remember, one of these is twice the size as the other when you set this up. So try to figure it out. And maybe I should pull out a pen so I can figure it out myself. So remember, one of these is double the other. And I see somebody chatted me. Give me a sec because I have to actually do the work myself. Okay, I got my answer. Let's see. So I'm looking at the chat. Ruthie, and if I say your name and I say you're good, you're free to go. I have you as attendance. I look at this later and I just write it down. But Ruthie, you got it. You're free to go if you want. Layla, you got it. You're free to go if you want. Noah, Amelia, Abigail, Emily, Mari, and Sam, all you guys got it. And you're free to go. Jablanca,
Wait, it's not working.
you're free to go. Maya, you're free to go if you feel like you got it. Ben, good job, man. You got to go.
Were we doing 18?
18, yeah.
Value of x. Where's my calculator?
So if I gave you the freedom to go, you're free to go. So think about it again, if you're a little stuck. You do kind of want to set it equal to each other, but one of them you have to change because it's half of the other. Or another way to think of it, one of them you have to change because it's double the other. So think about which one you want to change. Just left. And once you send me your answer and I say you're good, you're free to go. That's how I take my attendance.
Oh, I got it. Oh,
There you
I
go,
don't know
Tyler.
why.
That's fine. I understand. You got it. Good job. And Emma, you got it. Good job. All right. You guys are free to go if you want.
Bye.
Bye. Just in case if you didn't know, if anyone's rewatching this and you're like, how did I get this? You know this part is half the size as this. So you want to do double this part. You could also cut this one in half, but I always like to double the smaller one, typically because I feel that it causes less issues with fractions. So I'm doubling this bottom one. So 16x plus 20 is going to equal 12x plus 40. Let's do a little bit of math on both sides. Minus 20 here, minus 4x here. 4x equals 20. Divide by 4 on both sides.
Why? I wasn't listening.
Tony, what's up, man?
I didn't know I was even on this. What's it called? I was making eggs and they got burnt, and I got